This was the same guy who had then applied for the patent. And then a few years later, had a very different recollection of history. And this was like right when the SEC investigation hit in 2005. Our stock was down. We're fighting for our life. And I come back from a lunch. I'm worn out. We're in the foxhole. There's shells falling all around. The company's at risk. And I see Max in the parking lot.
I was pissed.
And he's red-faced, having an argument with our patent attorney. And I remember coming up to Max and saying, hey, what's going on? And Max, no offense, he was so angry he was inarticulate. Max was like, oh, he was like, he'd fallen back into Norwegian. I barely understand what he's saying. And then I remember our patent attorney looks at me and goes, Rick, I have a confession. We have to deal with this. I am the inventor of the X26.
Oh, wow.
And I'm like, what? And he's like, and I want $10 million.
Yeah. And that's after we had paid him to execute the patent.
Yeah, it was like 2 years later.
Yeah.
And that was one where
he wanted $10 million.
Yeah, it was a shakedown.
Let's boldly go.
Welcome back to the Boldly Go podcast. Today we have a very interesting guest. And Rick, you can tell he's an engineer at heart because he's brought not only lots of props you can't see down here below you, but there's a lot of things down here. And he has notes. For those who know the Boldly Go podcast, you and I mostly wing it, but not for Max. He's the original electrical engineer, I believe or the first electrical engineer.
I don't know. I've seen Max as a wing it guy. I'm going to share a wing it story about Max, but I'm going to wait.
I'm impressed, though, that he has props. I know you're going to like this. The first electrical engineer at TASER. So he's been here for a long time. I think he holds more patents on the TASER device than anybody else outside of maybe you, Rick.
Oh, no, he's got more than me.
Got more
I'm
than
sure
you.
Of that.
He's VP of
Research
and engineering, but that titles don't matter to Max, and we just all know Max.
I think you're a technical fellow now, is that
correct?
Right? We have
fellow.
Freed him from babysitting duties to solve interesting technical problems.
And come up with new solutions to problems that nobody knows exist.
So I would say if you are using a TASER device or you know anything about a TASER device, this is the guy who had a major hand in where we are today, where we got started and where we are today when it comes to tasers. Is that correct?
1,000%. Welcome, Max.
Thank you so much. Appreciate it.
Maybe we just start. And, we were joking around before, like sometimes like, well, Rick, how did you meet Max? And then, or whatever the guest is, and Rick never remembers. So why don't we start with you, Max? Like how did you meet TASER? How did you come in contact with TASER back in the early
I had finally found my dream job working for a big company called Intel. They had stock options and 401k and all kinds of fancy stuff, big labs. And then an engineer I worked with in the past, he called me up and said, Max, this is a small company up in Scottsdale. It's called TASER. I'm like, TASER what? It's like they make something called a stun gun. I'm like, what's a stun gun? So it's like, well.
Now, who was it who called you?
Mark DeSalvo.
All right, okay.
Yeah, I worked with him at AED, where I made about 700 different types of power supplies for laptop manufacturers from all over the world. So anyway, he called me up. I stopped by the office. I think it was a Friday. Come into the conference room. You were there. Your brother was there, and the engineering. And you told me that you've been trying to develop this new stun gun. And you gave me a 5-page schematic. And I look at it, and it's like, wow, this is complicated. So I was like, I asked to take it home. And I took it home, came back on Monday. And I met with all of you. And I spent maybe 15 or 20 minutes on the whiteboard. Explained that if the components were perfect, this would just blow up instantaneously. But
did I act like I understood the
of
schematic?
Course. Yeah, okay, very good.
That's right. That was going to be my.
Yes.
So, but since the components are not perfect, you could power it up with a car battery, and you will get some kind of an output. And I had an argument with engineering there, but I'm not afraid of arguments. So then I was asked to leave the room. So I was like, oops, no, I had maybe said too much. So I waited in the hallway for 5 or 10 minutes, and then I was asked to come back in. And then you and Tom asked me politely if I could design this circuit for you guys. So I'm like, yeah, I could do that. I gave you a fixed price. I don't know if you remember what the fixed price was.
I don't remember.
It was 20 grand.
Yeah. We paid you that much?
Yeah. And based on the 20 grand,
oh, whoops, let me come back in close there.
I gave you a circuit board. That was the first M26 circuit board.
Wow.
It has about 50 watts of input power and 26 watts of output power.
Wow.
That seems like a lot of money back then.
Yeah.
It did, yeah.
And of course, I had to argue with them. Why so much? Then you had to go through it. And then we weren't quite happy with this.
Wait, just back up for 1 second. Like, who had put together the schematic, Rick? Do you even remember? Like, I mean, you guys aren't a bunch of engineers.
Definitely wasn't me.
Right. And Tom's not an engineer.
No.
So I call it, when I started working in 1991, everybody wants to be a digital engineer because the PC was going hot, right? And then the first company I worked with had some problems with power supplies in cars. We tested with GM, -20 to +50. Power supplies were resetting. We couldn't buy anything online. So the director of engineering said, Max, we need a better power supply. So that's basically where it started. We started making power supplies because we couldn't find anything on the market.
Well, I will tell you, before
analog.
Max, yeah, finding people that know analog power supplies was hard. Look, I don't, but so my knowledge of electricity came from my high school physics textbook. And I remember asking questions about current and voltage. And for example, current is a flow of electric charge per second. And I remember talking to a lot of guys with like master's degrees in electrical engineering who were like, no, there's no time component to current.
Yeah.
I'm like, wait a minute, like that's like high school physics. It's interesting as people get levels of expertise, they get lost in all the details. And so Max was a pretty rare cat where he like started, I would say, with all the physics, and then understood how the circuits would actually work.
I mean, what do you remember about walking in that room? I mean, you just described what happened, but here you're a serious fellow.
Yeah.
You know this stuff. You're working for a real company called Intel.
Yeah.
Like you walk in and you run into Rick and Tom, and I'm not sure who else is in the room.
Well, so I had experience, I had joined Intel roughly 1 year earlier, into a group of 200 people. And I had a lot of respect for Intel. I mean, holy moly, coming into Intel. And I just worked for small companies. So I thought, I know nothing compared to the Intel people. Then I come into Intel and it's like, wow, out of a group of 200 people, whenever somebody needs something done as far as analog, power supplies, op amps, I was the guy to come to. So it's like, this time when I met with TASER, I'm going to use the digital engineers, and I call them, application engineers. They find an app note about the power supply, and then I copy the app note. And then I think, now they're power supply engineers. But they're not. I don't really understand how it works. They just copy something.
Well, I told you he came with props, and he brought a piece of history right here, Rick.
So that was just the power supply portion. Then we said, in order to improve the TASER, and I already gave them a fixed price quote. So in a fixed price quote, let's make something that's outstanding instead of just average. So we scrapped that. And then we put in a much bigger circuit board. And we put a microprocessor on there. But more than that, we also put a real-time clock on there with a backup battery. And before this, there was no other non-lethal or lethal weapon on the market that tracked usage. So we put all of that on the board, and then we put a data port on here. So each time an officer is using this weapon, it's a real-time clock that tracks it. And later on, we found that was super useful.
Yeah, to prevent and avoid potential abuse scenarios.
And it was all included in the first price. Because it was
I was pretty cheap at the
happy.
time. Well, Max, in fairness, at that point in time, I never knew where we were going to get the money to pay the light bill at the end of the month.
Yeah.
The month was starting, so we were hand them out.
And I was happy to make the customer happy. So.
I'm actually. You should probably look back. You might have had to take an advance out on your credit card or your Discovery card to pay Max's fixed price.
Oh yeah, this was the dark days. This would have been 98 or 99. And that's when I was recommending to shut the business down. I didn't think we were going to make it. My dad was like tapped dry. Yeah. And it's right about the time he and Bruce put their last dollars in.
Yeah. Do you remember anything about this Max coming in, and you're like, any thoughts of this guy coming in?
Yeah, I remember thinking he was a little crazy at first, but to me that was a good thing. It was like, okay, this guy's a little rough around the edges. He's not afraid to offend people and tell us that our design was a piece of junk.
Oops.
Well, you like that. You like people to be candid and honest with you. And now, just remind everybody, where are we? Which device and where are we in the history? We've covered the history before, but
so that came into this device called the M26. This is a see-through version, and one of the design aspects was 8 AA alkaline batteries. So I maximized how much power we could get out of the 8 alkaline batteries. Because the thinking was that if the officer had low battery, he could just run into the nearest convenience store, buy 8 batteries, and replace them.
Wow.
That was the thinking.
Yep.
But this was your first commercial or success with law enforcement that you got it right.
Correct. The M26 was the transformative product that saved the company.
And this is the first. So this puts at about 7 times more power or charge than any prior stun gun in the world. So this is the first weapon that didn't depend on a voluntary muscle contraction. On this one, it causes involuntary muscle contraction. So it doesn't matter what you think or what you want to do. This will contract your muscles.
This is the one that took down Hans Morero.
This took down Hans Morero.
To go back to the very first couple episodes we had, you could see that this is what you discovered. Everyone probably there early, especially back at that day, when they thought about TASER, they thought about Rodney King, or that image of Rodney King. And this is what you discovered, that device, which is not the company at the time, your company at the time, was underpowered.
Yep. And by the way, Max, were you involved in us building the test rig that we took to Stratbucker's farm the very first time? Or was that was right before you? Because I think we had the...
After I joined us full time, I remember flying out to Stratbucker farm. We strapped a pig, or had a pig on a hay bale. And it was anesthetized. And then we shot him with a taser. And we used an analog fishing scale to try to figure out how much the pig is contracting.
Yeah, it was pretty wild.
That was.
And by the way, Stratbucker, this is the guy I think we may have talked in a previous episode. Mm-hmm. The New York Times did a hit piece on us where they filmed him on his tractor and tried to make him look like a redneck hick because he lived on an asparagus pig farm. He farmed asparagus and pigs. But this dude was smart. MD, PhD, nuclear cardiologist. Brilliant guy.
Super smart. And it's so interesting. I mean, each time I saw, I remember we were up in Vegas for a conference and I saw Stratbucker. I'm like, hey, you want to have breakfast or lunch? And so I'm like, no, we have 3 hours before the conference. And I asked a couple of simple questions, and we had to run to make the conference because no matter what, he could go off on a tangent and explain the beginnings of electricity. Super duper smart. He's one of the smartest people I ever met. And then it's portrayed in the newspapers and mass media. So,
but
asparagus farmer.
He definitely had farmer hands, though. I remember when you were talking to Strat, he always had dirt under his fingernails. Hands that had done a lot of work in their life.
Yeah. He was smart as a farmer.
Yeah. Well, I mean,
there's a lot of smart farmers around.
Absolutely. And but still that just the image of, now we got this Norwegian. No one can't tell from the accent. I don't think I said he's Norwegian. We have this Norwegian and this pig farmer / asparagus farmer, and you guys out there trying to figure out, are you getting this right with the
TASER kind of a motley crew.
Yeah.
But
we did it.
Must have been fun days, though.
Yep.
So you got the power right on the M26.
Yep. And then they started manufacturing this thing, and I was still working at Intel, and they had slow growth.
Slow but steady. We were growing for the first time, though.
Yeah, for the first time. And I went to the kickoff of this thing. I think it was in 2000. They kicked this off.
It would have been, we introduced it at IACP in late 99.
Late 99. I still worked at Intel for a couple of years. Then in 2002, Rick came up with a new specification called an X26. It was supposed to be a 2-shot, I believe, and cheaper to manufacture. So I looked at it and I said, Rick, I'm sorry. I'm too busy at Intel, or I don't have time for this. And then they decided to give me a full-time job offer. I was a part of the Norwegian Armed Forces in Lebanon as a United Nations soldier, was a medic. And the only non-lethal weapon we had was talking, right? We didn't have any non-lethal weapons. Mm-hmm. And if you think back on the American Revolution, if the British had stun guns, there wouldn't be a Boston Massacre. There wouldn't be any upheaval. So I was like, and up to that point, 2002, there always been a conspiracy between Microsoft and Intel. Microsoft would come up with more inefficient operating systems, and Intel would come up with bigger processors. But Microsoft had just come out with a new operating system that was more efficient. So you can work at Intel and try to make the processors more, run marginally faster. It's like, how interesting is that? Then you have this small startup company, maybe 20 people roughly at the time, total revenue of about 7 million. Could join them and try to change the world, come out with a new non-lethal weapon. It's like, yeah.
Now, we were already public, though. Many people not know, right?
Yeah, you were already public
in 2001.
Already public. And something that people don't realize now, this is 2026. Everybody wants to join a startup. Back in 2000, nobody wants to join a startup. Are you stupid?
Yeah.
That's the comment I got. My family, my friends, everybody I knew, except for one person, Rick Stanfield, called me stupid. And my girlfriend at the time was so mad that she cried.
Oh, wow.
How could I give up Intel, stock options, 401k, benefit plan, fancy lab to go and join a startup? I mean, it's like, it doesn't make any sense.
And not even a cool startup in Silicon Valley. A startup
No,
in
I mean, this
Scottsdale,
TASER
Arizona.
stuff, I mean, it doesn't even work properly. I mean, not that many people believed in it.
But just to back up on your, you were in the Norwegian Armed Forces, as you mentioned, and UN, was it UN peacekeeping force in Lebanon?
Yeah, in the UNIFIL.
Like, how much did that influence your thinking in terms of like, hey?
A lot, especially I remember it was New Year's Eve. As a medic, the city I was in had 1,500 people before the war. No, it was down to 74 people. As a medic, I would go and treat them. One person cut his nose off. I put that back on. Somebody else had cut their finger.
Wow. Sorry. Rick and I are just looking at each other like.
How do you cut your nose off?
You know.
Is that like a lawnmower accident? Or?
No, they were collecting fruits with a big knife, and then somehow the knife slipped and cut the nose off.
Wow.
So, and as a medic, I mean, it's in the middle of nowhere, and I had all the necessary equipment, so I stitched it back on. I stitched some fingers back together. But so on New Year's Eve, everybody's drunk. I was on guard, and our sergeant, he was asking some civilians to leave in the most unpolite manner I can imagine. And some of the people there, they promised they're going to go home, get their guns, and come back. So I went up there. I had a rifle at that time, guard, and I say, hey, my friend, I know your mom, I see her once a week. I come here to treat her for this and that, I know your mom, I know your family, And as I'm talking to him in a friendly manner, I let my rifle poke him in the belly, like pretending I didn't notice. I said, hey, please go home and come back tomorrow, because my sergeant is an asshole, I know. So that was what kind of what avoided a gunfight, just treating people with respect. And we didn't have any tasers, so it's either a gunfight or there's no fight.
All right, so we make you the offer to join.
Yeah.
Then what happens?
Then I sign on the dotted line and I accept it. And I get ready to tell Intel I'm leaving. And then I get a phone call. It's like, Max, sorry, we have to retract the offer. We can't afford to have one electrical engineer on staff.
Was that you who retracted the offer, Rick?
Probably.
Yeah.
Hey, man, I watched every dime.
Yeah.
So
yeah,
it was...
Right. So
they
give
we were
you an
concerned
offer.
about overstretching ourselves.
Give you an offer. They call them retract the offer.
Oh, yeah. And then some days later, maybe a week later, I get the call again. And their dad, Phil Smith, is a big-time risk taker. He's like, no, boys, we need to have at least one electrical engineer on staff if we're going to be an electrical company. So
it sounds kind of obvious in retrospect.
Yeah.
So Phil jumps in.
Yep.
And we talked a lot about Phil, and he says, hey, guys.
They need at least one electrical engineer to be an electronics company. At least one. So then I joined, and of course they didn't have an engineering office, but next to manufacturing area was a small room. It's about the size of a small bedroom.
Mm-hmm. It was a broom closet before Max got it.
Exactly. It was a broom closet.
Literally a broom closet.
Mm-hmm. Yeah. So we clean up the broom closet with all the brooms and stuff in the back corner and so on. Then we got a plastic folding out table that became the lab bench. And then, of course, the company didn't have money to buy lab equipment. So I brought in my own soldering iron, my own oscilloscope, signal generators, components. So that's how the engineering office of TASER started. Nothing fancy like today.
Yep. Remember it well.
Yeah.
Do you miss those days, Max? I know Rick misses those days. He talks about it often.
It was fun to be on the ground floor and invent something new. And you could go and talk to the CEO. It's 1 minute away. I say, hey, Rick, what do you think about this? Or think about that? And you could have confrontations on a daily basis. I like to call it constructive confrontations.
And some of his confrontations are constructive.
Yeah. Yeah.
All right. So actually one of my favorite stories, it's right about this time that Max got pretty excited about the opportunity at TASER. And back then we had, not only we'd gone public, we had the stock where you could buy, and stock represents a little piece of the company. We also have these things called warrants. And warrants are much riskier than stock. Basically, a warrant was the right to buy a share of stock at a preset price. But the thing about warrants, they're like stock options. They can be worth a lot of money, or if they expire and the price is below that level, they can go to zero very easily. Do you remember what the strike price was on the warrants?
No, about around $9.
Yeah.
So first I bought stocks, and I refinanced my house, bought stocks in Axon or TASER. Then I took out a home improvement loan, bought TASER stock, and I also had some credit cards. Bought TASER stock on my credit cards.
And I think it was when, if I remember correctly, the stock went down. Max basically sold his shares and moved it over into the warrants, which were much higher risk.
Yeah, the stock was at $16 and the warrants were at 8 or 9. So I could double up with the warrants. So I did that. And of course, when the stock was up 10 times or 20 times, then you get...
And now at the time, I was counseling Max not to do it. My dad, as we've talked about, a very high risk tolerance, but I watched him make a lot of money, lose it all, which he lost the first time really in TASER stock. But before that, he had been the CEO of a public company, and he had options that went from being worth $0 to $20 million to $0 to $20 million to $0, never sold any. And so that had an impression on me where I'm a little more conservative. I'm like, hey, you don't want to put everything in one basket. So I'm sort of talking to Max. I'm like, I don't know if you should do this. It seems pretty risky to be leveraging your house, your mortgage, your credit cards, and putting it all into these super high risk warrants. But how'd that work out for you, Max?
It worked out fantastic. It worked out really, really great. I mean, back then the stock was, well, it has split now so many times. So, but maybe like $1 or $2 a share, and now we're up to 600. So,
Wow.
yeah, not too bad of a return on investment.
Yeah. I mean, are you a natural risk taker, or you just believed in the company that much?
Well, I mean, to put this in perspective, this is Max has become a pilot since then, and that investment's now bought more than one airplane, right?
I have 3 airplanes. I have a jet.
Oh, wow.
I have a aerobatic aircraft that I use for competing in aerobatics. I also have a backcountry airplane, like a Cub that can land almost anywhere.
So Max, one of our highest risk-taking investors.
Yeah.
There's the other one. I think we told the story of Chester Scott, the school teacher from Ohio. It's the only guy I know might have been riskier than Max, but
it didn't pay off for him.
Did not pay off for him. Max traded it well. That guy unfortunately got wiped out when the SEC story hit in 2005.
I knew Max was a pilot, and I knew that Max flies his own jet because I was in an Uber a couple of months ago, going to the airport for a trip. And the Uber, I think I had on, as usual, an Axon shirt. And the Uber driver says, "Oh, you work at Axon?" I say, "Yeah." He goes, "Do you know this guy named Max Nerheim?" And I said, "Yep, of course I know Max." He goes, "Yeah, Max flew the entire, was it your daughter's travel basketball team or soccer team?" Yeah. He goes, "Yeah, they had, I guess, a trip in California, a game or tournament in California. They all loaded up on Max's jet, and Max flies the team and the parents to the soccer game or whatever it was and flies them back to Arizona."
Yeah.
It's amazing. Were you taking risks like that elsewhere, or like you just believed in the company at that time?
I just believed in the company.
Yeah. I believe in you, Rick, but that is to mortgage your house, to buy stock on credit card or the warrants on your credit cards, so to max out your credit cards. That takes a big leap of faith.
Yeah. I still have about 70% of my net worth in TASER stock or Axon stock.
Yeah. Well, I mean, people like if we had Hadi on, and like Axon stock is the only, is known as a investor and an entrepreneur and everything else, but Axon is the only stock that he owns.
Yeah.
Wow.
All right. So coming back to, we made a comment earlier about, Max's risk taking and perhaps his organizational skills. So I remember one of my favorite stories with Max is he comes up to me in the office and he says, "Hey, Rick, I'm thinking about redecorating my house and I'd love to get your input on this." He's going to redo his kitchen. I said, "Okay." So he invites me over to his house. And, I'm expecting to look at some sketches and stuff. And I show up to Max's house. You remember this? And he opens the front door. And it is a disaster inside. There's like plastic covering everything. He's torn the kitchen out. And there's like wires hanging from the ceiling and drywall. Like somebody went through this thing with a sledgehammer. And we're standing in the kitchen. And Max is like, "So I'm thinking about, should I put the sink over there or over there?" And I'm like, holy Moses, dude. Like, Max is an action first kind of guy. I was expecting, he was going to have all these plans to talk about. He's like, nah, he tore out the kitchen. We'll figure it out later. That was really funny.
Did you help him with his design? I mean, you love that stuff.
Yeah, I do love that stuff. It was a lot of fun. But the fact he had just torn the house up first, it was great.
I thought he was organized. He actually
Bias for action.
He is the first guest in all of the history of the Bold to Go podcast that actually brought notes. No other guest has done this.
Oh,
that's why I thought he was going to be organized. So you wouldn't fly with him, Rick? Is that what you're trying to tell me?
Like, I don't know if I want to go. I love Max to death. But for example, I will not be a pilot because I would kill myself because the inattention to detail. I have avoided flying with Max because I love Max to death. I think he's brilliantly smart, but I just worry that sometimes people that are too smart maybe don't follow the rules as strictly. Like my brother's a pilot, and my brother is like a by the numbers kind of guy. But Max has been doing it for a long time. I know a lot of people flown with him. Now he's doing aerobatics and stuff. So.
Well, that is crazy. Back to the TASER devices. You get it shrunk down to the X26.
No, that hasn't happened yet.
No, that hasn't happened yet. So, I started working on the X26. And Rick wants, of course, a lower cost. But in my mind, I want much smaller size. So I'm trying to make the waveform more efficient. Because M26 uses a lot of power. I mean, it drains those batteries, and it's hard to make that smaller.
And folks that don't know, like you're competing for space on an officer's belt.
Yep.
Like where they're going to use it.
Yep.
M26, which you have in front of you,
Yeah.
is a big weapon. So it's always a matter of bulk and weight and size to try to make sure it can fit on the officer's belt.
So first I'm trying to make the M26 more efficient. But already it's running roughly 75% efficiency. So say if it's running 100%, now we can have 6 batteries instead of 8. That's not enough to call my mom in Norway, I say, hey mom, I reduced the battery count from 8 to 6. No, it has to be better than that. So I was wrestling my head. And so on the M26, it delivers one big blunt pulse. It's up to about 50,000 volts. And then as soon as you make connection with the skin, it drops down to much lower than that. So it's kind of like pulling your car with a bungee cord. Bungee cord is maybe good for snapping, but it's not good for pulling your car along. For that, you need a steel cable. So I was trying to come up with a concept where we could ionize the air first, and then once the air is ionized, send an arc through it.
Now, by the way, I got to jump in here as well. The original business plan I did was to do a very small TASER that could fit inside a shotgun round. And that, again, was based on the simple high school physics textbook that power equals current times voltage. And the idea was if we could lower the voltage from 50,000 volts to 500 volts, we could deliver the same amount of current with 99% less power. Everything would get smaller. So we were planning to go test that, where we had gotten an Office of Naval Research grant to go try to do the research on this smaller power supply. And we were getting indications that that was going to work. And then Max...
Let me jump in a little bit. So the Office of Naval Research came over to our plant to kick off the research. And of course, I saw the engineering office, the size of a small bedroom, with the folding plastic table was the lab bench. Then we're sitting in the conference room and...
Didn't inspire confidence, I guess.
I mean, kicking off the meeting in our main conference room. And I asked one of the doctors, captains, whatever he was, if he wants a cup of coffee. And he goes, yeah, I have a cup of coffee. So then we go over to a coffee machine, and I ask him what he thinks. And he goes, this is the biggest waste of time ever. I don't understand what we're doing here, We have so much better than this. This is a waste of time. Government money. I have no idea what we're doing here. And, that was an opinion. In my mind, that was an opinion. Okay. Go ahead, Rick.
No. Keep.
Did you know that part of the story?
Oh, yeah. No, they... Well, and we had proposed that with this research, previously when we'd tested on the pigs, we just sort of visually observed the amount of muscle contraction. And so Max and Matt Carver, another guy who works with us, had come up with this idea that we lovingly called the pigerator.
Yeah, because in all my engineering experience, you need to be able to track it. Like if you release a mechanical drawing, it should have tolerances on it. So then when somebody makes something for you, you can make sure it meets the tolerances. Electrically, you do the same thing. And then when we test the TASER on a pig, if the pig is not anesthetized, it's going to run around and scream because it's painful. So then we want to put the pig to sleep so he doesn't react to pain. and we want to come up with a waveform that is maximum effective at locking up the muscle with as little power used as possible. But of course, the problem is TASER puts that up to 50,000 volts arcing to go through clothing. And if that gets into the instrumentation, you're going to blow up the instrumentation. So the technician I had was Matt Carver, super mechanical, smart guy. So we came up with what we call the pig aerator. So we strap a pig in there, and we hook up to all 4 limbs, and then we use sensitive instrumentation to measure in real time the muscle contraction on all 4 limbs.
So the pigurator was basically, it looked like an exercise machine for a pig with a bunch of instruments on it. And I don't want to get into still some of the proprietary secret sauce stuff that we do, but there was a way to adjust the tension on it. And it involved a sandpaper break on a rope. And I remember we showed this to the Office of Naval Research folks. And they went and they looked at it, and they said they had like 12 physics PhDs. And they came back and they said, this will never work. They ran the calculations, and it would violate the laws of physics that our sandpaper break wouldn't hold the rope in place, which by just sheer common sense, you're like, what? Like, this is not like, we're not breaking the sound barrier here. We're literally going to put 2 plates with the sandpaper, clamp it together, and hold the rope. And like, no, it's never going to work. That'll slip. It can't, da, da, da. And so they gave us all this critique, and we were, we were a little put off because we're like, man, this is U.S. military. These guys are like, they build nuclear bombs and shit. And they're telling us we're a bunch of idiots. Yeah. But we built it anyways. We said, okay, well, we're going to go. So they said, fine, you guys go do your thing, but it's not going to work.
And at the same time, I had this breakthrough. I had a whole box full of transformers and capacitors and stuff. So I come up with this new concept, working where I was actually able to create an arc through the air. And that arc that ionizes the air makes it conductive. But then as the air is conductive, you need to send a second pulse through that conductive air, through the ionized air, at the same time, or just after it. Because if not, those ions disappear in microseconds, in millionth of a second. So how can you do that? So I had finally figured out the circuit.
And by the way, I'll just come back from a simple like high school physics perspective. What Max was doing, he took the low voltage X-rep circuit and the high voltage M26 circuit, and they had a love child that basically said, I'm going to do a small high voltage pulse and then deliver through that arc of electricity the lower voltage pulse, and the whole thing should get much smaller. Yep. And I remember when he first told me that, he was like, that's an awesome idea.
Well, I remember it slightly differently. I remember I got it working on my lab bench, and it was just a bunch of wires here and there. But it was arcing, and it was discharging. And I ran to your desk. I was like, Rick, come and look at this. I got it working. So you came over. I was like, oh, okay, interesting. Okay, yep. I have some emails. I have some more emails to do.
Yeah, emails are important, Max.
Yeah. But of course, that was just a breadboard, not even a breadboard circuit. It was just a bunch of wires and transformers and capacitors. That was wild science. And then we refined that circuit, and we took it to the pigurator, and it worked absolutely beautifully.
I've never heard the name pigurator like this. I've been to the pigurator.
It's a trademark, trade secret.
We better get the URL on that as well. And just remind everyone the reason that pigs are so important to this testing.
Well, and yeah, like, to be honest, once people heard that we were testing on pigs, PETA, the People for the Ethical Treatment of Animals, they put us on their hate list. They would come to our shareholder meeting every year in a pig suit. And I'm like, look, like, we're making weapons to save lives. Nobody's ever done the research. People would say, well, why don't you do a computer model? Well, computer models need to be based on research. Nobody's ever done the research. Nobody can tell us how much electricity it takes to cause muscles to contract and to do it in a way that doesn't impact the heart. So you got to test on a complex mammal. And so we don't want to do it on people. And so pigs were great. And pigs were especially great because their hearts are electrically super sensitive, because on the outside of the heart, you have the nerve fibers, whereas a human,
fibers.
Yeah, whereas a human has those nerve fibers inside the heart. And because the nerve fibers are on the outside, it's easier to shock the heart and cause a problem in a pig, which makes it a great test subject, because if it's safe in a pig, it'll be safe in a human.
And also the skin and the flesh. And
for years, PETA would come to our shareholder meeting. And look, I'm not afraid to stand up to people and I think they're wrong and they're bullying. So we would only serve meat products at our shareholder meeting. We'd offer them burgers and sausages.
And they never came to my garage where the actual research was happening. Most of the early pig research was done in my garage.
And as a reminder, the way a TASER device works is it causes neuromuscular incapacitation. So Max did mention it's a stun gun. It doesn't stun you. It causes the contractions, as we've discussed here many times. If you get the right connection to spread, and it causes the muscles to contract and lock up where you can't do anything.
Yes, we need a certain electrode spread. We typically say 10 or 12 inches of electrode spread. Then we can excite large enough muscle groups that you're going to lose control of your body and fall to the ground.
Oh, and by the way, when Max says we were testing in his garage, some reporter heard about this and ran this hit piece story.
Yeah.
Like, here's these bunch of rednecks with a farmer who's their medical director, and they're shocking pigs in Max's garage. Like, I've been to university research labs, and I will tell you, Max's garage was way more high tech. It's not like your average home garage. He was running a Jiffy Lube. He had like automotive lift machines, and we'd bring in veterinarians with all the right equipment.
Right.
It was way more high tech than any of the universities I've been to. But the headline was that we were just a bunch of cowboys.
Well, I mean, it does paint that image.
Yeah.
I mean, so is this the innovation that gets you to shrink it down?
Yeah. So by doing that, we got a roughly 6 or 7 times less power consumption. But still, with the X26, we're using about 70% of the power to create the arc, and maybe 25 or 30% to create the muscle response. So there was some push to make the muscle response even stronger. But in my mind, if you have a decent spread, the X26 will perfectly lock up the muscle. So it's no reason to make it stronger. That will just decrease the safety margin. So we stayed with a pulse that was roughly 120 microseconds long and 120 microcoulombs.
Yeah. This meeting, I do remember when we brought in our patent attorney, and Max was super excited. We knew this patent was going to be really critical to the future of the company. And I remember Max explaining this over and over to our patent attorney. The point was getting a bit frustrating about this high voltage spark and low voltage follow through. And I remember the patent attorney finally, this light bulb went on. He's like, oh, this is similar to how strobe lights work on airplanes, because he had done some patents on aircraft strobe lights. And apparently they also do the same technique where, for a different reason, but they'll hit with a high voltage spark, cause the spark to light up in the strobe light, and then they lower the voltage to keep the light on longer and sort of drag it out, so it makes a brighter flash with less energy. And I remember Max was like, yes, you finally got it. Well, this was the same guy who then applied for the patent, and then a few years later had a very different recollection of history. And this was like right when the SEC investigation hit in 2005. Our stock was down. We're fighting for our life. And I come back from a lunch. I'm worn out. We're in the foxhole. There's shells falling all around. The company's at risk. And I see Max in the parking lot.
I was pissed.
And he's red-faced, having an argument with our patent attorney. And I remember coming up to Max and saying, hey, what's going on? And Max, no offense, he was so angry he was inarticulate. Max was like, oh, he was like, he'd fallen back into Norwegian. I barely understand what he's saying. And then I remember our patent attorney looks at me and goes, Rick, I have a confession. We have to deal with this. I am the inventor of the X26.
Oh, wow.
And I'm like, what? And he's like, and I want $10 million.
Yeah. And that's after we had paid him to execute the patent.
Yeah, it was like 2 years later.
Yeah.
And that was one where
he wanted $10 million.
Yeah, it was a shakedown. We had that serious discussion at the board level. Like, should we pay this guy? Like, we're under all this pressure. And now our number one patent is being attacked by our own patent attorney. And like arguing over inventorship is really hard because like, how do you prove who had an idea first? And his story was that he shared with Max the idea that he had from the strobe lights in aircraft. And that's when Doug Clint, our then attorney, came up with a fantastic plan. He's like, hey, we don't want to argue about who, he said, she said, and who invented it. Instead, let's go after this guy for harboring a conflict of interest against his client. And we won. We got him disbarred. And to this day, but he actually went and he changed the patent application and put his name on. Years after we made the application, he put his name as the inventor. And we let it ride because the right legal strategy was not to challenge the inventorship, but to challenge him on harboring a conflict against us. And the court awarded us the patent, but it still has his name on it, which I know sticks in Max's craw. It's up on the wall.
I've been wanting to go and white out his name on it.
And I mean, what do you remember other than being incoherent, speaking Norwegian, yelling, turning red face?
I remember that, I mean, this patent attorney, I had to explain it to him so many times. And he did not have a good understanding of electronics. And what he thought was that putting two diodes in parallel, where one feeds a low voltage source and one has a higher voltage source behind it, is the same thing, which is basically how the patent that he was referring to was doing it.
I mean, and Mike, you know that, like diodes, that's clearly not the same thing, right? I mean, I could see it in your face.
Well, I kind of zoned out as he was talking.
Yeah.
So
Yeah. I mean, we have 50,000 volts. And at that time, a 50,000 volt diode would be a huge monstrosity of a diode. There's no way we could package a 50,000 volt diode into that small taser.
So
We're back to
he does not. So this lawyer obviously does not understand the
it was
the electronics behind
that was crazy. That,
Yeah.
I mean, and then I found out that my secretary at the time was working for short sellers against the company. I lost a little faith in humanity in 2005. That was a rough year when your own attorney turns on you, your own,
who you're
executive
paying
aide.
to do this.
Yeah, that was rough.
Yeah.
But there was actually a fun story in there. As we were developing the X26, we were on a research trip. And Max, you're a hunter, right?
Yep.
And I'm not. Like my brother's a hunter, I'm just not a hunter. But we were having this debate about, hey, could this enable catch and release hunting? And lo and behold, we're out in the middle of nowhere. I don't want to mention where because I'm not sure if the statute of limitations is passed. And we see a deer. And we're like, hey, pull over.
No way.
And I think, Max, were you the shooter?
Yeah.
Max manages to hit a deer with a taser. We run out of the car, take a picture. Like when hunters kill a deer, they take a picture with it. We come out, we take a picture with the deer. And then we let it, deer gets up and runs off. Like the first and perhaps only catch and release.
I mean, again, this is a handheld taser. Like
that's the X26
shooting a deer with a handgun. You're shooting it with a handgun taser. It's not a long rifle. Yeah. How far away was it, Max?
It's about 10, 15 feet, 15 feet.
I'm not sure that deer will ever get that close to a car again. But look, Max and I have both been shot with the same taser the deer was. And compared to normal hunting, far more humane.
Yeah.
So do we have pictures of this that we may?
We are searching the archives. If we find them, we'll put them in the
and
final
then we'll
edit.
check with our chief legal officer, make sure statute of limitations is passed.
But while we're on this topic, we have had customers tell us that there's a need for large animals. Sometimes like the Alaska State Patrol with bears, etc. And so we made a variant of this called the MX Animal Taser. But you got to test it, right? You can't give it to customers and be like, hey, we think it might work. And so we went to test it at a local bull farm. And man, did that work. And we hit this bull and it just went stiff and straight over to the ground. And then we went to pull the darts out and we realized one had hit the bull in the side and the other one hit it dead center midline of the testicles.
Who pulled that one out?
We didn't. That one had to fall out on its own. We all felt pretty terrible about that. But it did work. The bull was fine, and we have had customers use taser weapons on some pretty large animals in dicey situations.
Well, I mean, we've shown the original video way back when, some of the early episodes, Jack using the buffalo gun, taking down the buffalo.
And I would tell you, we're working on a next generation consumer taser for self-defense. We might make a bear version because I actually believe the next generation of consumer taser is going to be more effective, have more stopping power than a handgun. Especially bears are hard because of their thick skull. A lot of times a handgun won't stop it. So Max and I have not even talked about this, but we might do a spin of a bear-focused self-defense taser weapon.
Okay. Max has his backcountry aircraft. You guys can load up.
Yeah, that'd be nice. Then I could take it anywhere and not worry about gun regulations from state to state.
Just back up for the second on the deer thing. I mean, it's a pretty big moment. I mean, I know you're driving down the road, you see this deer, you hop out, you use the X26, excuse me. Like, I mean, that's got to be still some excitement. That you're able to hit the deer, but that you take the deer down.
It was pretty wild. I think, it was.
And this is, of course, before the X was launched.
So with the X26 smaller, it works.
Well, we thought it worked. And actually, that was before Christmas of 2002, we had a pretty working prototype. We were supposed to launch it in beginning of 2003. So I'm like, that's too much stuff remains to be done. And they're like, no, we're going to launch it. And I'm like, no, I'm going home for Christmas this year. And Rick and Tom and Phil are like, no, you can't go to Norway for Christmas this year. We're launching. So it's like, no. We had a big argument. So it ends up me in the conference room with all the big bosses. Then I pull up my Microsoft project schedule. And, Phil, their dad, has run companies before. My Microsoft project schedule had about 400 line items. So I started going through one by one. And after the 20th or 30th line item, Phil goes, Max, have a nice Christmas holiday in Norway. So I went back to Norway for a couple of weeks for Christmas. Then we came back just to make sure everything works.
So Max's strategy was to bore my dad with details.
Yeah, of course. So after Christmas, just to make sure, let me shoot Hans again, Hans Marrero. If you can take down Hans Marrero, you can take down anything.
Mm-hmm.
So right outside my office, we strap up Hans. Luckily, I also applied instrumentation to him, oscilloscopes, so I can see what's going on. So we fired the X26, and Hans doesn't go down. It was the strangest thing.
And you taped the probes to him.
Yep. We taped it to his jeans,
Yep.
Yeah.
to his leg.
Yep. And he didn't go down. Yeah, it's like, what happened? So luckily again, I had it on the scope waveform. And in all the prior testing we have done, we have one probe inserted and the other probe arcing to skin. And we can arc about 40 millimeters, almost 2 inches.
But importantly, one dart is punctured through the skin in all the testing we've done. In this case, we taped both darts on the outside.
Mm-hmm. And then when they arc to skin, we find out it instantaneously dries out the skin. And it creates a barrier. And that barrier takes about 1,500 volts to punch through. 1,500 times 2 is 3,000 volts. But I didn't have more than 3,000 volts on that capacitor that was supposed to discharge for the muscle. So this circuit wouldn't work.
It was extinguishing the arc early, and we weren't getting the power through.
Yeah. So I had to completely redesign the circuit. And of course, plastic is done. There's no more room.
I think this is like February, and we were planning to launch in May. And we'd already bought the ads. We'd scheduled the conference. Like, that ship was sailing.
Yep.
So we couldn't push the date out.
Yeah. So had to double the size of the capacitors, double the power consumption. Everything was basically double. So it's 2 pounds of stuff in a 1 pound box. It was really hard to make that work. And nobody made the capacitors we needed. So called around. We found a small company on the East Coast. And they said, yeah, they would be willing to work with us. But they had to custom order the film. And the film would be here in April. So it's like, okay, we pay money down. And so come April, we have the new circuit board. And the capacitors show up. Both the big orange one, which is the one to create the arc. And then we have 2 what we call muscle capacitors. They showed up, and lucky, it worked. It worked. It was April, and Rick had already started running ads. So
we had a teaser campaign.
Yeah.
The X26 is coming.
Yeah, 1 hint per day. And so we built up 16 prototypes by hand. Sonia did a great job for us there. And we had to paint them. Milan Zurich was the only mechanical engineer on the team.
You launch it. You make the deadline, you launch it, and get it out there.
We made it work.
Yep. So we show up to Florida. And at this time, we had shot myself and Rick and a few other people.
And Hans.
And Hans.
We shot Hans for sure.
Yeah. But we hadn't really tried it on a large population. So we showed up at the conference. So this is Colt 45. And then we come up with this. And we're saying that this is 5% more powerful. And the officers go, that's impossible. How can that small thing be more powerful than the big thing?
Hold the X26 back up real quick. So one thing we did, an interesting design decision, we made the handle intentionally annoyingly short because we wanted everybody complained the M26 was too big. And we're like, you know what? We want them to complain that the X26 is too small. And then we'll sell an extension just to make it like annoyingly small, like really lean into it. And that was it ended up, I think, being a genius decision.
So over the conference, we shot 150 officers. with this. They also shot me at the same conference.
I don't think
You shamed me into taking another hit too. I'd already taken my hit. Max
But
is
you
like,
had to in public.
Max
yeah.
in front of the whole group is like, "Hey,
Yeah,
Rick,
yeah.
you're going to take a hit?" I'm like,
Yeah.
And I remember that one because in that case, when I got hit, they shot me in the back and my arm shot out like this. And it was in this weird position. And I had this, when you get hit with a taser, time slows down for real.
Mhm.
And I remember looking at this and I'm trying to pull my arm back in and I'm embarrassed. And I'm thinking, God, this is an embarrassing situation. I'm like, I feel like Stephen Hawking because my hand is in this weird position. Oh man, must be frustrating. This must be, and I'm having this whole conversation with myself about how Stephen Hawking must be really frustrated that he can't control his limbs. And I'm having this empathetic relationship with the famous physicist and blah, blah, blah. And then after what seemed like an hour-long conversation with myself, then the current was over.
which is only 5 seconds.
It was only 5.
I had the same experience when you're falling, and we did it differently. You guys probably have people holding you up as you're falling. I scream because all the air is coming out of your lungs. And I remember saying to myself, "I'm going to die." And as I'm going down, this young intern is holding one arm. He still works here to this day. He goes, "It is almost over." Now it sounded like it was like that slow. It is almost over, Mike. But it was like 5.
Get ready for the pearly gates.
But
Mike.
it was like, no, but it was like 5 seconds. But I just remember the whole slow motion thing down and him saying, "It is almost over, Mike."
Yeah. Actually, we forgot to mention something here. I'd like to take us back in time until the late fall of 2002. So we have been doing all this research on with the pig generator. And we were able to quantify the effects of voltage, current, charge, pulse rate, and so on. And we're writing up a report based on that. Well, Rick is writing it up, actually. And then we have the summary meeting with the ONR. So the same people come out here,
Office of Naval Research.
Office of Naval Research, based on all the PhDs and the doctors. They presented first, and they were very proud of their research.
And by the way, when they came out, there was no shortage of arrogance.
Oh, yeah.
And we were intimidated too, because these are the
yeah.
guys who already told us we're idiots. The big rater is not going to work.
And there's a bunch of doctors and PhDs.
And we're waiting. I'm waiting for like NASA level shit, like, quantum
Ground
computer
shaking.
stuff. Like, we're going to see how real research is done.
Yeah, how real engineering is done. Not just some...
Guys in a broom closet.
Yeah, in Scottsdale. So then they start out. And it's like, we go to different pigs, and we starve them and we put them in an enclosure. And then we have all these weapons that we tried. We have the M26 and we have this and we have that. And when we shot the M26 in the hind leg, they will be running with their front legs. And this one pig, he jumped over the enclosure. And, with the other one, they could drag their feet less than with the M26. Blah, 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 blah,
So
blah.
let me translate this. What these guys did, they put the pigs in an enclosure with a bowl of food, and the pigs were hungry.
Go.
And what they showed, ready for the shocking result? If you shock a pig, it won't eat while it's being shocked.
Yeah. But
And the pigs were not anesthetized. And then they made no research equipment. They just shot it with the old Tasertron
In an enclosure.
and the new M26. And that was it. And then they discovered the pigs won't eat with anything. And if you hit it with the M26, it'll fall down. And if you hit it with the old Taser, it would, in some cases, jump out of the pen. And that was the totality of their research.
Their findings.
And we're literally thinking this is a practical joke. We're like,
yeah.
there's no way.
And then it's break. And after the break, we present, or Rick presents our findings. And, this is the first time in the history, just take it into perspective a little bit. I mean, people have been making stun guns, taser weapons for over 30 years. And nobody had even tried to quantify the effects of it or quantify the safety margin. We did that. We actually made waveforms that were stronger than the taser weapon, made them up to 50 times stronger. And we applied those waveforms to critical areas of the pig, close to the heart. And then we could quantify how much stronger the waveform would have to be in order to fibrillate the heart. Nobody had done that.
So, by the way, Max had made me these beautiful charts. We could show every muscle contraction of every limb. We could quantify it using a certain algorithm. We're not going to share because it's a secret sauce, but we had beautiful precision, and we could tune up or down to hit a very specific, and we decided to make the X26, what about 5%?
5%
Stronger than the M26. And we could show that it took 16 times the dose across the heart before we could cause a fatal arrhythmia. And that, as Mark Kroll would famously help us quantify, that is a higher safety margin than Tylenol. Because if you take 8 times the dose of Tylenol can kill you, we were up to 16 times the dose of the X26. So we had both really good effectiveness data, highly quantifiable, and for the first time ever, a safety margin index similar to pharmaceutical products on a weapon.
Yep. So we present all of that in the meeting. And then after the presentation is over, I asked the same doctor if he would like a cup of coffee. He's like, yep, sure. So we go over to the same coffee machine. And I asked him, what do you think? And he goes, this is the most impressive research I've seen in my whole life.
Wow.
That was a good moment.
That's amazing.
That's a good moment.
And now, Max, you worked on, I mean, these are seminal moments that made the company and got it going. And you've worked on all the tasers since then. We're now at Taser 10. I mean, what was your favorite one that you worked on? Was it these early versions, getting these breakthroughs, or?
Taser 7 by far.
I was not expecting Taser 7.
Yeah,
Why Taser 7?
I did not think he was going to say that either.
So before Taser 7 research started, I remember sitting in a conference room called Franklin with top management, including Ulrich. I was like,
oh, wait a minute. We don't have a Franklin conference room anymore, do we?
Well, that's a different story.
Oh, what is it called today?
We'll
leave that in the air for a moment. I'll see if Max wants to unveil that.
I would like to unveil that.
Well, why don't we just talk to conference room for a second, then we'll come back to Taser 7, because I have a story about that. So yes.
Well, we were in the conference room talking about Taser 7 in Franklin.
Yes, no, we're in Franklin. We talked about the next generation tasers. So you and then Doug and there's management agreed that after X2, there couldn't be any more improvements on taser. I mean, that is like the peak of technology. And I'm like, no. And they're like, so Max, what is it going to be? I'm like, I have no idea. But if you had the first Colt revolver in 1849 and you said, there's going to be no more development on the revolver after 1849, we would still have an 1849 Colt, or we'd have a 1911. So I have no idea. But before we started research, we have no idea. And then one summer, we had 3 interns coming in, and nobody wanted them. So I said, well, I'll take them under one condition, that I work on my pet project. People were like, well, okay then. So over the summer, we worked on different concepts, putting the wire inside the dart. And I've been asking about that for years and years, but everybody knew that was impossible. You can't spool out the wire that fast and so on. That's just not humanly possible. But when you get interns from university, you can harass them any way you want. And you can tell them that you want to do this and you want to do that. That's what I did. So at the end of the summer, they present what they did to Rick and the management. And at the end of it, remember what you said, Rick?
I don't remember.
So Rick goes, this is so funny. This works much better than the standard cartridges. And everybody else are making cartridges the same way as we are today. And this putting the wire inside the cartridge is a game changer. So it's funny that everybody else, including us, we have been winding the wire inside the dart in a Circle 8 configuration, and that's best as it could be. Nobody questioned that.
Yeah, and when he says everybody else, we had a Brazilian company that copied us, and I think a couple in China.
Yeah.
So the Taser 7, so you're excited. I mean, the Taser 7 is memorable because of the cartridge design.
Yeah.
And I mean, this gets to your point, Rick. I hate to point this out that you say all the time, as recently as last night when we were doing something that, with age comes wisdom, but then also you stop thinking about new ways of doing things. You get these young folks in,
stuck in your ways,
and why are we doing it this way? And you had 3 interns, and
But before we get to the Taser 7, that's going to bring a little bit of perspective into it. I mean, Rick, this was your first company.
It's his only company,
and nobody had really told Rick how to be a CEO or how to run a startup. So he's learning on the job. I haven't really had a course on how to start an engineering company from scratch and hire mechanical and drafter. And so we're all learning on the job. So it was a big learning
I'm a little nervous where this
I
one's
know.
going. Yeah.
Yeah,
Dun,
yeah.
dun, dun.
Yeah. And for example, this circuit board, that's the main controller board for the X26. Has about 5 power supplies on it, a microprocessor with an amazing amount of memory. It has 8 kilobytes of memory, versus the M26 had 2 kilobytes, and that was program on time only. This had 8 kilobytes.
And I got to say, it has this display, which you can see right up here. You can't really see it over there, but that was modeled after Sigourney Weaver's weapon from Aliens, where that had the 2-digit countdown display. I don't know if you remember when she's fighting the mama alien, and we were like, we got to put that on ours. And we use that for like a countdown and battery display. So first weapon with a
battery percentage.
Yeah.
We also put a memory inside the battery pack. So we could manage and tell the officer how much battery percentage was left on the battery. And on the TASER, it's using very little power in standby, and then a lot of power when it's actually arcing. So there's no way of measuring such a big difference in current. So in the X26, we're actually predicting how much current or power we're using from the battery for each operation. And then we just subtract that from a bucket that's stored inside the battery pack. That's how we display the battery percentages from 99 to 0. So I made that schematic, layout, and so on. Tested it a couple of times. I remember this time it was myself, electrical engineer, Matt Carver, technician, and build everything and so on, and Milan mechanical. So this was supposedly working, and we got fantastic response. So I tell our supply chain, please buy components for as many as you think you can make in 1 year, but don't populate the boards. There's a high chance that maybe there's a trace or something that needs to be changed. A couple of months later, I found out that about 15,000 finished circuit boards with components placed. So luckily, I didn't screw anything up, but we had 15,000, and the year before our sales were 7 million. So that was almost two years worth of X26 sales. Like
big bet.
Big bet.
Big back.
It worked.
As you mentioned about the countdown and the numbers in Sigourney Weaver in the movie. Like just hit like how much sci-fi. I mean, how many sci-fi movies and images and things like that has seeped its way into all of our product designs?
I'd have to take some time to count. I would also say like the body cameras, the head-mounted camera. Our inspiration to get live streaming also came from James Cameron film, the same one, Aliens. Remember, Apone? He's got the live stream.
I'm just picturing like we got a serious engineer here who knows electricity, and you're coming to him with these ideas. We're like, hey, you ever seen Alien?
Yeah. Hey, man, the arts is good at envisioning cool stuff.
Now, you said when I asked Max that question, you didn't think he was going to say Taser 7. Did you think he was going to say Taser 10?
I did expect that, yeah.
And because there's a very famous story about Max and the Taser 10, when you were trying to fit as many cartridges as possible, as we discussed in Taser 10, and then you were trying to figure out how you were going to fire 1 trigger pull, 2 trigger pulls, and then...
Oh, yeah, let me see if you remember this the same way, Max. So, yeah, the engineers that come back said, we can fit 10 cartridges in. Well, our initial thought was, well, okay, that's 5 shots of 2. But then we had this debate about, well, wait a minute, if you miss, you probably only missed with 1 dart. So should we shoot 2 darts and then 1 for every subsequent trigger pull? Or who knows, maybe we should shoot 3 darts, like 1 at a close angle and a 3rd dart at a steeper angle. So it would be 3, 1, 1, 1. Or should we fire 1 dart at a time? I remember Max saying, well, hey, if the job is to get a connection as fast as possible.
What did you say, Max?
I said either 2 or 3, possibly 3 darts the first time.
No. You said, let's shoot them all. I don't know if you're being serious, but like the blunderbuss and just shotgun blast. And we're like, okay.
Well, you get credited with that story because Rick tells it a lot to our customers and always gets a big laugh. And some people were thinking like, yeah, well, that would work if we had done that. But no, that's not how we designed it. Because ultimately,
we decided to build 1 dart per trigger pull just to test it, even though everybody we asked said that's a terrible idea because people are used to how things work. And what was amazing, this has influenced how I think about customer feedback. Mm-hmm. Sometimes you have to build it and they have to experience it for them to give you good feedback. Because when they imagine what it might be like, it's hard to imagine the experience. And then those same people, as soon as we put it in their hand and they shot it, they're like, oh my God, this is so easy. Now I just place each dart. I don't have to think about angles and trigonometry and distance and all that. I just pick my 2 points and go.
Yeah.
So I'm big on getting customer feedback with actual things they can experience, not just thought experiments.
Yeah, and I'm not afraid of being wrong. I'm afraid of not trying the things I'm opinionated about and proving myself wrong.
Mm-hmm.
And I'm actually really proud of my group right now. The first thing I tell people in my group is they're not there to prove me right. They're there to prove me wrong. And I was in a conference room maybe a year and a half ago with a bunch of new college graduates and a couple of people from my team. And I said something. I don't remember what I said. But a team from Eric Bretner from my group, he said, Max, you're wrong. I thought about it. I said, Eric, you're right. I was wrong. And I think that's
Maybe you
really,
guys should get married.
Yeah.
It'd be like the first marriage in history where that gets.
But it's really important that the people that work for you, can speak up and prove you wrong. I mean, they're trying to get to the correct answer as opposed to my answer. And if you remember in the propulsion module on TASER 7, I was really excited. I had this new company and new propellant we're going to try. It's going to be fantastic. So I flew out of state. I used a bunch of credit cards and spent a week on it, built up many, many prototypes. Every prototype was a failure. So I wasted 1 week to prove that my concept did not work. And that's all it took was 1 week and some expenses. So then we were free to move on to something that would work.
I think we should back up, and this might be a good way to start wrapping up this episode, Rick. Like you mentioned the conference room. So it was called Franklin after Benjamin Franklin.
But I can mention something else. I was so happy one day. I'm usually not asked, my opinion about what the new stun gun should be like or whatever. Mm-hmm. Rick typically has someone in product marketing or...
Usually it's Rick.
Yeah, Rick or product marketing. So I get this invite, it's like, Max, this is a meeting in Franklin. And they're going to discuss what the next TASER stun gun should look like. So I show up to Franklin. I'm really excited. I have my ideas in there. I'm really happy to be telling what I think it should look like. Then I come in there and Rick is there and a bunch of management is there. They go, oh, surprise, surprise. And they renamed the conference room to Nerheim.
It's amazing. It's the only conference room named.
And he was, I'm guessing you were probably disappointed that we weren't there to actually talk about that experience with TASER.
I mean, still haven't had that discussion yet. But.
Well, I would tell the reason it's fresh in my memory. We just had a meeting with a bunch of police chiefs this week in your conference room, Nerheim conference room, and this police chief looks at me and said, "Oh, what's the interest? There's a picture of Max in the conference room. I don't know if it's an oil painting, but it looks like a Renaissance painting of Max, and it's on the wall." And she looks up. She goes, "Who was that?" And I said, "That's Max Nerheim, not famous guy." And she's already seen all the our patent wall has all the patents. It's like more patents than anybody else. He is the guy that invented TASER. And she goes, "Well, he must have been a really good guy." I was like, no, he still is a good guy. He's not dead. She goes, "Oh, but that picture up there, I thought he had passed away and we had named the conference room in memorial." And I said, "No, Max is still live and kicking and inventing and helping push us forward."
I have another story I'd like to share if you have time.
Go for it.
This is the Axon Pro.
We've only seen pictures of these lately.
Yeah, so this is the one that has been on the prior podcasts. And Rick was telling her how expensive it is. So I kind of came here to set the story straight.
Oh, no. Here we go.
So this project was kicked off in January. Originally, we had a smaller unit, but CEO wanted something bigger. So this is a belt buckle on the backside.
The bat belt.
Bat belt. So the officer has a belt buckle. Then he can flip it down.
I still got to tell you, the belt buckle's beautiful.
And there comes the screen.
Didn't fly in the market, but boy.
There comes the screen.
Gorgeous.
And of course, it's hooked up to the camera that sits on the head. Kicked off the project in January. We had to pass the video, high-speed video, through a coax cable. So I think it's 8 or 10 signals in here. Go into the world's smallest high-speed connector that sits on the side. This cable cost us $200 to make. But
which was more than the targeted cost that we had for the whole system.
The device.
Well, we introduced this product with this titanium holster at our conference that year in the summer. So this was a 6-month product. So I would say this was a great success because it showed that the customers did not want this. And we only spent 6 months to deliver something that the customer did not want. We didn't spend 2 or 3 years on it.
Ouch. I got the message. Yeah, we now spend way too much time to get to that same point.
Now, I do feel like I'm sitting here with...
That's a fair critique. And that is going to be a change in.
I'm just looking at you to... Now, I do feel like... You ever seen Carrot Top? Where he's got his bag of tricks, he reaches in and he pulls it out. I do feel like that with Max. Like, he does have a few more things down here. We were going to wrap up the episode. But Max, let me ask you, is there anything else down here in this bag of tricks you want to pull up and show us?
Here, let me see that. I hadn't seen the bat filled in forever.
Before we wrap up, a la Carrot Top.
Oh, look at that. I love the bat. That was so fun.
Max, he's going to try to bring this back. Like, this is going to...
Yeah, you know, we have so many things to talk about. We haven't talked about the C2 or the Shark Bay, really not the TASER 7. There's so many interesting things to talk about, but I think I could be here all day long. So if you want to wrap it up, I just have to come back like 3 or 4 times.
We will bring Max. We had to have Espen on. We've had the Norwegian on. I think we did him twice, or we did 2 episodes. We'll bring, maybe it's...
I'll have to bring Max back. Right. So anything else you want to wrap in today?
I have a question.
Maybe we'll do like the Team Norway and we'll bring Espen and Max back together.
Do you guys get together and jam, you and Espen, now that he's here at the company? 2 Norwegians.
We do. You know, there was a mention at the CKO or a company kickoff this year. We should do more skunkworks projects. Mm-hmm. So when Espen was here, just after CKO, I showed them a skunkworks project that my group is working on.
CKO's company kickoff.
And he was super excited about it. So we're working on it right now.
Wow. I'm going to have you tell me about it after the cameras
we
go
shut
off.
down the microphones. And just, I guess, you know, not trying to make, we talked about this many times. You talked about it, like things incrementally better. And we made a big jump from 7 to TASER 10. I mean, maybe just as we wrap this up, like, what are you excited about, Max, in terms of like the future of TASER devices and where you think we're going?
I think I'm excited about finally seeing growth throughout the world, especially in Europe. Like Norway right now, you know, is big time into TASER. And I was just thinking about this yesterday. In 2005, we had 200 ongoing lawsuits, so much negative press. I remember going to a conference in New Orleans, and somebody brought up that this weapon puts out 5,000 watts or something. So I went over to Robert Anglin at Arizona Republic, and I said, you know, this is powered up by 8 AA batteries. The way I made it is that it pulls the maximum power I can get from 8 AA batteries, which is roughly 7 volts at 7 amps, about 50 watts. So when somebody's saying they can get 5 kilowatts out of this, like, you know, 6 horsepower, that's no way. I mean, you get more power out than you can put in. So I said, you went to high school, right? And have high school physics? It's like, yep, I got it, Max. I understand. 2 days later in Arizona Republic, first page, how Axon or TASER is killing people. Then you open up the paper and it's a double widespread. All these people have died from TASER. You know, we cannot reverse the effects of a drug overdose with electricity. And there was so much negativity. And you wonder how many people are dead that could have been alive today because some of these journalists had to get a click, an eyeball.
Amen.
Well said. Well, Max, we're definitely going to have to have you back for sure. Rick, do you want to take us out of here? This is where you say something inspirational about Max or like something about the evolution of TASER devices, but I think we need to sum this episode up.
I'd just like to thank you, Max, for having the courage to always challenge the conventional, the courage to be wrong and be wrong quickly. We are kicking it into high gear this year to move our product development back to a little more startup jam, move fast, prove things fail quickly, and up our game of innovation.
I appreciate that.
To save lives.
Yeah.
Well, thank you, Max, and we'll have you back.
Let's boldly go.